what the fuzzer does, it will loop over all these input parameters, generate a random value for them if it can, and then invoke the procedure. And it will then store the results into another JSON file. So let's see if we can get that to work. Did I type it correctly? Invoke. See. If I can type correctly. First of all, we specify the necessary argument for the out path where it will store our fuzzing results, and we can just pipe the results file to the invoke fuzzer to specify our target file. Like this. And that's basically all it needs. So then it will just loop over all the procedures and start invoking them with our random generated input. So because it's 5 interfaces, it will loop or it will go over all the 5 interfaces and also over which endpoints it was actually accessible to see the differences between those results. And it will, based on the output, it will generate an allowed file, a denied file, or an error file. So if we take a look at the allowed file, we can see, for example, we were able to call RPC delete printer driver, and that contains some of our fuzzing input. In this case, it took 3 strings, so it generates these random 3 strings, and in this case, is a Windows message which says the file directory name or value label syntax is incorrect. And also, if we take a look at the error file, these are the procedures that we couldn't actually invoke. We see errors like no matching onion selector and marshalling onion 2, and this has to do with some structure issues. So yeah, that's a bit of the flow about how you can actually start using this tooling. I will show another demo, but for now I want to get back to some more complex things. So a large part of the functionality of the fuzzer is actually generating input values for the procedures that have input parameters. And for primitives like strings or integers, this can be quite easy because you generate a random value. But there is also more complex types of input parameters, for example, context handles. And if you find a procedure that needs a context handle, you will first of all need to call some other procedure to actually get such a context handle. And a context handle, you can think of it as a session token, because sometimes within inter-process communication, it will need to remember the state of some kind of information. And in this example, if we open a printer, it will return the session or the context handle, and then we can provide that context handle to another procedure to actually close the printer again, or do some other operation with it. By default, the fuzzer will create an instance for the context handle, but this is just a null handle. And a large part of the procedures that take a context handle and it is a null session or a null context handle, then it will just throw an error like, yeah, this is just an invalid handle. And that also comes down to a dependency problem, because by default what the fuzzer does, it will go over all the procedures in, for example, this order. But what you can see is that the first procedure here already needs the context handle, but the second procedure only gives us a context handle. So actually what we want to do, we want to turn this around so that we first of all call the procedure which returns that valid context handle, and then call the procedure which needs the context handle's input parameter. But there's another issue. And some procedures actually close that context handle again, for example, RPC close printer. And then the last one in this order then needs a context handle again, but we closed it. So then it's again a null session, or a null handle. So what we also want is to put the procedures that actually close our handle at the end. So then it doesn't matter anymore if we close it or not, because no other procedure needs it anymore. And I've done some research, and I've implemented an algorithm which actually does this. So it will first of all sort all the procedures based on the input and the output parameters that it needs. And then once it actually finds a valid context handle, it will store it to, and then another procedure which comes along within the loop that actually needs a context handle can take that out of the array where I store all my complex types. And then it will actually be able to invoke it with a valid context handle. So that's nice. I've implemented that within an argument which specifies which Fuzzer type to use. And in this example, I provided the sorted Fuzzer type, which actually implements that algorithm. So by default, it doesn't use this one, because it can happen that this will provide other results that you perhaps may miss some vulnerabilities. So make sure to always test both of the Fuzzer types to see the differences between them. So let me show you a quick demo about how that goes. In this case, our target is going to be the spooler service again, but this time we are going to put our focus or the fuzzer at this RPC interface and also just over this endpoint. So then the fuzzer will be done faster. So we invoke the fuzzer. We provide the fuzzer type, which is now a choice between default and sorted. And also we're going to provide, in this case, an integer input, because in this case, what we don't want is generate random integers, but we always want to provide an 1 as an integer input. And also I want to look at what my IP address is, because opening a context handle can be quite picky. In this case, to actually return a valid context handle for RPC open printer, we need to provide our IP address as a string input. So in this case, our string input. What am I typing? Yes, our string input will be a UNC path of our IP address. Yes. And then, of course, I need to specify the right file. Let's see, spooler. Okay, thank you. And also, I will be providing a blacklist because some procedures will actually hang, for example, like waiting for a change. So in this case, my blacklist contains one procedure, RPC wait for printer change. And then it will go over it. So if everything went well, and we look at the errors, let's see. So, sorry, I will just clear it to make it a bit more clear. Yeah, okay. So the thing I wanted to highlight on is this procedure, because when we actually invoke it, we suddenly see an error message that the AOPC message request is no longer available. So this could mean that something crashed. And if we take a look at the event log of the event viewer within Windows, go to the Windows logs system. Takes a while. You will see that the spooler server suddenly crashed. And that's interesting because I'm running this as a low privilege user, and the spooler server is actually being ran as a high privilege identity because I cannot stop this by normally. And now I'm able to crash this. And remember that we over which endpoint we actually were able to crash this, and this endpoint was exposed remotely. So this is a vulnerability that I discovered recently and yesterday published a blog about. And I also prepared a demo for proof of concept to show the actual exploit on a remote system, but I don't think we have enough time for that. So I recommend, if you want to learn more about this vulnerability, to take a look at my blog, because yesterday I published a blog about this vulnerability. So let's get back to the presentation. The last part is analysis, because as you have seen, I went through the JSON file, but that wasn't really convenient. It took a long time to actually find some interesting things that actually happened. So, for example, if your JSON file is 50,000 lines long, you want some solution to actually pick out the interesting interactions. And this is where I thought it would be a good idea to use Neo4j to actually show the relations between our data. And this is where the commandlet import data to Neo4j comes in. So what it does, it uses Neo4j, which is a database to show relations between your data, and you can query the data using cyber queries. And I've written a commandlet for that, so you can pipe your phishing results, your JSON file, to the import data for data to Neo4j. And then you provide your credentials and your IP or your system where it actually has this Neo4j database running. So this can either be remotely or locally. And then if you provide the right cyber queries, you will actually be able to map the relation between your data. So this provides already some more insight. But we invoke a procedure, but we're still talking about black box filtering because we actually have no idea if we invoke a procedure where our input lands on the system. So to get a better insight into where our input actually lands, we can use a tool, for example, Process Monitor, which is a tool within the sysinternals, which monitors processes. For example, you can view which process it starts and how it interacts with the file system within Windows or the registry. And you can apply filters to it. So remember when you see those random strings being generated by my fuzzer, they also contain this static string, which I call the canary, which no other thing on the operating system will basically use. So I'm sure that if something pops up using that string within the path, that it was my fuzzer that actually did it. And if we take a look at that spooler service, for example, it will interact with the registry using my strings. So based on my input, I'm able to let the entity authority system open some kind of key on the path that I chose. And this process monitor file can actually be exported to a CSV and then imported into the Neo4j database as well. So now we have our fuzzing input results and a log file for process monitor. And now we can actually map that Windows 32 functions to the input which I generated using my fuzzer. And this opens some new ways and to get better insights into interesting procedures. For example, we can map for registry rights because we just make a cyber query which contains reg set or reg write, and then it will map exactly which fuzzing input led to this function call. Or, for example, privileged file operations, where I basically wrote a rule that if it's being executed by a high privileged identity and it contains the Windows 32 function call file, then it will mark it as a privileged file operation. And that, of course, is interesting to read as well. So, some results. I found some service crashes, remote and local, just as I've demoed the spooler service, and of course quite a few more. System crashes where I was able to BOCD systems, a nice CV and a bounty, some spoofing vulnerabilities, and even more. Future work contains like testing multiple paths, because now we still have an order where we kind of sort it, but we also want to test different kinds of orders to see if that will lead to other results. And also structures within RPC are a thing that are more complex, and to generate the right structure for the input parameter is something that I need to work on, because a lot of procedures take a structure as input parameter, currently it's creating just a default instance for this. But actually what you also want to include your random inputs to this string, to this structure, to see how it actually behaves differently. And of course, to see if I can find more vulnerabilities. So that's it, wrapping up. Thank you everyone for listening, and I hope you learned something new today. Are there any questions?
Thank you for the presentation. That was really interesting. The question is, did you try to, so since you know which DLL on the file system provides the RPC functionality,
yes.
You can disassemble it and check what caused the exception and why the service became dead. So did you try to learn by this route?
So you mean like the example of the spooler service crash?
Yeah.
Yeah, so you can also read it on my blog. I disassembled it using Ghidra and also WinDBG, and it's basically a null pointer being dereferenced.
Yeah, thank you. Actually, I read it.
Okay.
Yeah, already. I didn't expect to meet you here, but yeah, thank you. That was interesting.
Thank you. Are there any more questions? Otherwise, I will be around for the confirmation the whole day, so let me know if you have any more questions. Thank you.
Thank you very much. Due to fantastic time management from our speakers, our coffee break starts on time. So from 11:30 to 12, coffee will be in this area. There is still, you can catch the rest of the talk in the main track in the meantime. And without delay, please enjoy.
Cool to show like bleeding edge research as well, like really recent research, and present that as well. I mean, also adds like in real touch.
Yeah, thank you.
Yeah.
I'm still waiting for even though they say it's a public security issue, they still want you to provide like a draft of your blog to actually show this to the public.
Okay, but they did.
thing is you have to at least get 2 weeks before the deadline also for your actually disclose your credibility. Well, they didn't respond within the deadline, so I said like, yeah, well, according to the rules, I will be publishing. So if they are mad, I will see. I know the correct.
No, that's great.
Thanks. Ja, super.
Wij zijn ook is ook nog een half uurtje. We gaan even opzetten. Ja, ja, precies. Dat
Oh yeah, so I removed that buffer. I decided to go here's just Okay, sure. Yeah, maybe. And especially songs or
Hallo. Hey, goeiedag. Check nog op de bergen.
basically I can just use the same record that I read.
I have vision.
So it's basically copy-paste.
Nee, doe niet.
Maar ik kreeg hem om het bord te zijn.
Ik heb er iets in zo zitten.
Goed opgeleid weer.
Kun je nog wisselen met iemand?
Nee, ik probeerde elke mogelijke tijd te missen, maar alsnog, hè.
Probably by an account.
Misschien kunnen we de eerste animatie overslaan. Nee, dat is duidelijk. Dat is met hen is gekomen. Heel duidelijk.
microfoons.
Gewoon deze en de microfoon.
Ja. Ja, deze was dan voor de spreker en de mic voor de MC of zo, de vragen.
Ja, klopt, maar ze hebben 2 sprekers van dan.
Oh.
Ik zorg wel dat ik weer teruggeef op mijn mic. Ja.
Mijn collega van de andere kant die komt er even aan, die is echt super videotech, beter dan ik.
Ja, en anders staat, we hebben geen demo of iets, het is gewoon één presentatie van onze slides. Nou, als het niet past, als het niet lukt met dit ding, we hebben geen demo of iets, we hebben een presentatie.
Deze wil even niet. Die wil niet. Die wil niet. Dit is mijn collega Laurens. We kunnen niet.
Ja? Ja?
Kijk, ik ben een helphout. Wat was er met...
Wie van jullie wil deze? Ja? Zullen we even door je shirt heen zien te krijgen? Ja. Dat is het meest makkelijk, hè? Ja, langs je rug.
Eerder. Maar jullie degene die niet willen opgenomen worden?
Ja. Oh, dat zijn jullie?
Dat zijn zij.
Oké, dan zetten we dat uit.
En mensen herkenbare dingen.
Ja.
Terwijl rond dan ook eens fiets, want het best wel veel nog gebruikt kunnen.
Oh ja, nou oké, dat is dat kind. En
Ja, dat.
Oké.
Ja?
Ja?
Ja.
Top.
Deze niet goed.
Niet subtiel, nee. Misschien, daar ga ik snel heen.
Wel vandaag, hè? Dat,
Jullie starten om 12 uur, toch? Nee, dan kan ik ook nog heel even snel een sigaretje roken.
Ik denk dat wel.
Ja.
Hebben jullie verder iets nodig? De tweede mic fixing, die zei tegen mij. Ik hou voor jullie de tijd in de gaten. Inclusief Q&A geef ik even de tijdsignalen. Ik zit in een regel goed achteraan. Mocht je niet over tijd gaan doen, dan ik geef de tijdsignaal aan. Voor even dat ik weer niet. Nee, dan weet ik het. Ja, dan weet ik het. En dat is wel wat. En dan moet je met de Q&A maar even kijken. Want dat met Mike, dan hoop ik dat jij een groot deel van de vragen kunt beantwoorden. En anders hol ik heen en weer.
Heel dichtbij.
Ja.
Nee, dat goed. Wel bij de dingen wel.
Het is het.
En moet je even bij de opening aangeven of geen foto's nemen?
Puur voor dat het gecommuniceerd is.
Nee, ja.
we hebben zoveel mogelijk net zo goed eruit gesloopt, maar zoals je ziet.
Ja, zit er niet in.
Ja, de screenshots zijn natuurlijk wel.
is happening now, that the factories and the warehouses, the logistics centers are connected well with IT so that it can fulfill the demand and speed up the process of supply chain. And it is going to be increased. But since everything is connected to the internet, connected through the network, we have a lot of exposure of attacks as well. So we've seen a few recently. One big news came about Jaguar Range Rover attack, which made them shut down for 5 weeks in production. So it was a bit of a misconfiguration and third-party vendor issue. Because of that, they have faced so much of loss in the business. Similarly, a few days back, Cloudflare also had an attack which infected whole internet and everybody, because Cloudflare is kind of backbone of internet, which also impact OT and supply chain business. Similarly, some more attacks, ransomware. One big name is MPM attack, which affected OT security a lot, and other important hacks which happened recently. So these are few examples, including Stuxnet, as big as Stuxnet attack, to tell you that OT security is not just about the computer, it's much more than that. It is about sensors, it is about the devices connected, it is about people awareness, and all the things involved. So what is the motivation behind having supply chain attacks? One is, of course, the financial gain. Everybody need money. Attackers also need money. So ransomware is one big example. I'm hoping everybody who worked in the supply chain environment knows about how big the ransomware attacks scenarios are happening, and it is growing, and there's hardly any control flaws into it. So we need to be very much proactive to stop the ransomware attack. Then intellectual property, which lies with any company or their vendors. So that can also be theft, and that can directly impact to the brand. Then, yeah, the recent example of Range Rover attack was also operation disruption. Just with a small issue of, let's say, Range Rover or Cloudflare, it impacted that bigly, very big, and also it impacted in their business, and they faced the loss. Then there are competitors in the market which want to do research in your business and try to make the name down. So that is strategic espionage is one reason for a supply chain attack. Then geopolitics is involved. It is much more than IT or business. It is about the governments who wanted to do bad to other. There are 3 big wars going on in the world. So yeah, OT and connected networks are on their target, and it's not so difficult to find vulnerabilities into those networks and attack, and probably just make them shut down for some hours. It will impact them big. And of course, including everything, it impacts the corporate brand value of any company. So the threat actors in this scenario would be application, because everything which is running in OT is run through applications. It runs on the infrastructure and network. So let's say in a distributed environment, if the network is not segmented and there are multiple vendors, third-party vendors are involved. So if the network segmentation are not there, one network can expose to other, and one vulnerability can travel through other network, and that's how the escalation can happen. Then multi-cloud environment is very common in supply chain, because it's not just one vendor, one company is handling. Every company has multi-cloud environment, so that's also big threat actor in that case. Then there are IoT devices and OT devices. Those are hardware chips, and hardware chips have vulnerabilities to be exposed, which can be researched, and very difficult to patch, at least for the OT environment, because for the companies, it is a big investment. The SLAs with the vendors are huge, but to patch they cannot afford a downtime. And just because of that reason, that downtime should not be there, sometimes we accept some risk which are very hard for the business. So that is the reason the hardware security, hardware risk are going more and more research are happening on the hardware security as well. Then there are supply chain risks which are related to third-party libraries, vendors, identity access management of multi-vendor ecosystem. And of course, there are insider threat because OT environment is mostly connected, but it's very easy if somebody who's insider can probably put just a USB in your system and try to exploit that. The big example is Stuxnet. So the new ecosystem supply chain is going to be big. It is going to be growing each day by day. So that's why it is going to become the best target for hackers and do research on security on the OT security. So I have a few case studies which I'm going to present and will be helpful for us to understand how OT security in supply chain can be harmful. So first example of case study I have of a hacking connected system. My goal is to find any sensitive information out of it. So architecture is something like we have a CNC kind of device which uses in OT environment. It is connected to a application server which connects to a backend. So it's a simple breakdown I did for this. So OT device, first of all, would be a device which can have a connectivity, first of all, have a chip inside it. That is the basic of any OT system. So there are few ways we can do enumeration into a device and try to dig down more what bad can happen in a device. So the process is something like if a researcher or a hacker wanted to want to know about a OT device, what he can first of all search about their devices from Google. So Google will tell, let's say I'm searching, let's say ping pong bar. What kind of coffee machines they use? Is it connected? I can search probably on Google that I saw an Nescafe machine, and it is connected. So Google is the best example of that. Then there are IoT search engines or OT search engine for connected devices, Shodan and Census. So in that, you directly get all the connected system list and also the open port and services running on that. And that is easy and public information which outsider or attacker can search. Then if you find that information, let's say I get to know that this particular device is using a particular brand, or that brand use a firmware which is on GitHub available. Maybe they've configured it by themselves, but you at least get the base code from GitHub. And if the library of GitHub of that firmware itself has some vulnerability, which is not yet public, that could also be one entry point for attacker to know about one particular device, and that device is connected to the OT environment. So from there, the attacker can plan the entry and attack into OT system. Then there are communication channels on the OT devices, like that it is connected to Wi-Fi, Bluetooth, and bus protocol like Modbus, CAN bus, IC protocol, and Zigbee, so on. So all these protocols have their own vulnerability. Wi-Fi can be attacked, Bluetooth can be attacked. Modbus and any other bus communication protocols also have their MITM, sniffing, and modification attacks which can be done. Also 0 days can happen here because of any vulnerability. Then there are communication protocol in it, COAP, MQTT, or web, or maybe custom port or custom services. Sometimes OT devices run on the internet. So sometimes generally what happens in OT industry is for the servicing, the manufacturer put a backdoor or a service port which is not patched or maybe not known to a company who is using it. But it is for easy servicing. But if attacker get to know or he find out, it can be bad for whole ecosystem. Then there are application interfaces which are on public, which can be exploited. So it could be on the web, or maybe a console machine on the top of OT, which let's say doesn't have authentication, but probably you can control the conveyor belt. So if it doesn't have, you can change the configuration if you are insider. So that kind of flow can also be there on the application. Then there are hardware interfaces which can be found by the research. So if let's say attacker have access to the device, let's say I'm taking the example of another coffee machine which this bar has. I can also buy it from market, do some research, and find vulnerability into it. If I can exploit it in local environment, I can also do it in the network environment. So if such scenario can happen, it can also lead to attacks on the network and supply chain network. So I'm taking one example of a hardware. Either it's a PCB or control system, everything runs on the PCB boards. In the PCB board, a few basics which we can find out are the debug ports. Let's say, for example, JTAG pins. JTAG pins are used for servicing and debugging on the interface. So if we find out, we can actually dump and interact with the hardware. So that is one. Then there are microcontrollers connected to function those PCBs and PLCs. So in MCUs, there will be firmware which can have vulnerability. It is also possible that it is not encrypted. If that's the case, we can also dump information from it. Then there are memory chips. For example, E2B-ROM. If the credentials or any, let's say, commands or the values are stored in E2B-ROM, for researcher, it's not very hard to get those information and try to do reverse engineering and malfunction the device. So these are few examples of hardware attack which can happen on the OT environment by the researchers. So I'm taking the example to exploit the JTAG port. Through the JTAG, we can actually, first of all, basically it was originated to debug the device, but it can also be used to interact with the device to dump the firmware. And by dumping the file system, you can also get to know what kind of key exchange happening, what kind of information it is asking or storing. So if we find that, we can find these kind of sensitive information or the keys from the devices. For example, the information was stored, let's say, personal information or public or private key for the vendor. So although it's a big machine, but inside it is a chip, and chip can be read out. So easy example is JTagulator. This is one easy tool for hardware attackers which they use to interact with the hardware. It can basically use to read JTAG, SWD, or any kind of debug port on a device. It's basically also automate so that you need not to actually know which pin connects to what. So it does the automation, and it's just easy to find out the port, and once you find out, you can read the information out of the system. So just a bit of example, like once you dump the firmware, how do you probably find out what's there inside it? So I've dumped probably a firmware from a dummy device, and I find out this firmware is not encrypted. So to read the data, I can just go into the Linux system and use the Linux keys Linux command to extract the information out of it. And you can see here, there are public and private keys are exposed if it is not encrypted. So it's just an easy tool to dump the information out of it. So if you understand that, the firmware was not encrypted, and by binwalk, this simple tool, I was able to dump the firmware, and from there, the private and public keys which were used to interact with the device are exposed, which can lead to bigger attacks. So simple misconfiguration at the vendor level can lead to a bigger attacks. Apart from that, there could also be some data which is stored into a device which can be read out and can be sensitive for the compliance and for the brand value. So to mitigate those risks, first of all, patch the latest level of the firmware, which is very hard in OT environment because in OT, the downtime is more crucial. We accept those risks because of not taking care of the timeline of the patching. So make sure that security advocates should enforce that the patching should be happening on the time. Then the encrypted information which we are processing or storing should be encoded and encrypted within the process on the channel that is on the network, also when it is being stored. Then the hard-coded credential and keys in a firmware or any device is not preferable. So one way, let's say I'm a security expert in my company and I'm trying to say, yes, I have a good PKI. So I'm trying to implement public and private key, but the keys are stored within the local environment. So that means it's not total secure. So we need to have a strong mechanism of PKI as well into OT devices. Then I also have another example of a Bluetooth device which is connected to a OT system. So to the target to do that, the goal is to do that is to find out any information from that device or to interrupt the operation. So architecture is something like OT system with a Bluetooth enable function, and it connects to an application and talk to a backend server. So what an attacker would do is, if it is Bluetooth enabled and attacker is within the range, it can try to search for that Bluetooth device, interact with its services, which is happening on the interface of GATT, G-A-T-T, and try to modify those services. If he can modify the GATT services, it can actually, first of all, malfunction the device, shut down the device, and if the device is shut down, that means it can also interrupt the operation of OT or supply chain, which impacts OT. So to go ahead, this is the process. I'll just go to directly a video which will show you how does it work. So if you tear down a sensor, it will have a PCB which is running with Bluetooth. And to run the Bluetooth, you need to have a probably Bluetooth 4.0, which is classic, or Bluetooth 5.0 with encryption. In the OT environment, we generally see the 4.0, the old devices are still being used because we cannot afford to replace them. And it is being used for, let's say, last 5, 10, or 15 years. We are still using it. But the problem is, those are already malfunctioned devices. We just need to take care of their security configuration. So if the old device is there, what I'm doing here is I'm scanning the Bluetooth device first from the GATT tool, which is a common GET scanning tool. It can be available on either on Python or probably in a mobile device as well nowadays. So I'll scan the device. I'll find out this particular Bluetooth sensor. Once I find it out, I'll try to connect it to its services on the GET network. So I need to connect to the GET database, and it is automated tool, so I need not to even write script for it. So I'll connect to the GET database, and then I'll find out services which are readable and writable. So if the services are writable, that means I can also write on that, right? In Bluetooth, let's say there are services for listening, audio, visual, and everything. So if the characteristics is writable, I can change its value. So what I'm doing in this video is changing one characteristics of one function, and by doing that, I'll try to malfunction this device. So it was writable, I put the value as something else, and the device was shut down. So it doesn't need a very big research as well. It's just a mobile tool which can hack your Bluetooth if it is not modern, if it is not securely configured, right? So this is another example. Then the mitigation for this vulnerability would also be secure configuration, because here what happens is, because of small get characteristics function which was not used but kept writable, I was able to rewrite that. So we should not put any misconfiguration in our devices. Also make sure that the devices which we are using for third-party vendors also are using secure configurations. Then another example we can take of Modbus hacking. Modbus is one of the protocol which is used in OT environment. Other examples are also like CAN bus IC protocol. So Modbus is also very common to do MITM attack if there is no encryption or authentication in that. So if, let's say, there is no segmentation in the network, and your Modbus device is running on one network, other devices on the same network can also sniff on the plain text communication. If the communication is sniffed, then it can also be used for malfunctioning. So this is like one example of the device which has support for Modbus. There are tools like MBSlave we can use to interact with Modbus. So if the communication is not encrypted, we can send command or probably try to interact with Modbus. And it is same as Bluetooth characteristics. If you put the offset value, it will reply for its characteristics. And in the Modbus, you can try to brute force all of the offsets. If you try to brute force offset and you find offset which is probably changing the value, then you'll be able to probably change the value of the Modbus function and the device will malfunction. Another thing can happen here is when the manufacturer make a device, they put the backdoor for servicing, and it can interact to the Modbus control commands. If by sniffing you find any function which is used for nothing, probably on a port, connecting to a port, or maybe used for nothing, then it is also possible that attacker can find it to misuse on the network. Plus, if it is not used, that can also be used to probably put back the backdoor on the device, and attacker can continuously monitor the device. So Wireshark, basic tool, and MBSlave, we try to do MBSlave interaction with the Modbus and capture the traffic. Here we found one function which were unknown. That was probably a backdoor from the vendor which used it for servicing. But if as a commoner, I get to know that this function is used to interact on particular port, I can also interact with that. And if there's already have access to the network, I can probably shut down the device or malfunction the device. So this is also one example of what OT device is lacking. Mitigation for this would be, again, encryption and authentication, because if Modbus commands doesn't have authentication, probably somebody who's insider can interact with simple tool like MBSlave. And then segmentation was not there, so that if somebody is there on the same network, whether it is a third-party vendor, he can also interact with the device on the network outside of the company. Because generally, we also provide VPN and network access. And if it is the same segment, it is exposed to third-party vendors as well. Then integrity check. Yes, of course, if it is affected, somebody changed something into characteristics, and we are not monitoring that. We're not checking the integrity of current state of the system. We will never know that we have a backdoor in our OT system. Another example of probably a mobile application I have. There are a lot of mobile application which connects to different sensor, humidity sensor, light sensor, occupancy sensor nowadays are there on OT. Those devices are also, if not properly configured, can also lead to an attack, and it is very simple. Because, for example, let's say there's a Bluetooth sensor, there's a humidity sensor which connects to a mobile app, which is from a company called ABCD. and I also use the same app at my home, and probably the device is discoverable. So as an attacker, if I reverse that mobile application and I know where it connects to, I have the backend information, probably I have I have some more vulnerability known about that application, I can actually attack that in the supply chain network. So in my example, I'm using probably a mobile application which serves to a machine. This mobile application could have insecure data storage, broken cryptography, it could have hard-coded secrets, and it could also have a back-end connection, but I need to find out whether I have information about backend server or not, if it is hard-coded in the application. So I'll directly go to the demo. This is a general analytics application I made for serving a server. And in that application, I could see that, yeah, I can do reverse engineering into it and do a reverse APK. Once I do reverse APK of this application, I can read out about the application code itself. So from the code, I'll directly go to the code. I could see after reversing that a backend server configuration was saved into the app file, and it was hard-coded. So that means even though I don't know about the company, I don't know about anything about the app, I just reversed one APK and find out where it connects to. And I have IP address and the credential of admin. Now if I try to connect to that with just simple Linux command, I'll try to ping this and then try to serve it on the given port. I'll use Metasploit for this, and through Metasploit I am connected to the system. So here you can see my system is connected to the backend server, which was hard-coded to the application. And once I connect it to the application, I also can harm the backend. So in this video, going ahead, I will also show you that the backend information is now having a root access. And in the backend, I can also read out information, who am I, and change a lot of backend. So if that is the case, this can also harm not only the web application locally or the device locally, it can harm the control, the full ecosystem of the backend. So these were a few examples of recent case studies of the devices worked on OT. The problems for this case study was that there was no encrypted information. The hard-coded server credential was stored in APK, and also if that is needed and the company of APK made a patch, maybe vendor did not patch it. So as a OT company, we should also be proactive to patch all the APK and update it. A bit of defense in depth, it includes everything, including server to the back end, to the front end, everything about OT security, zero trust zone, network segmentation, secure by design, communication protocol, everything need to be secure in defense in depth to make sure that supply chain goes smoothly. That was it about this talk, and if you have any questions, let me know. Just to give you a reference, you can connect to me. I'm also shamelessly open to work, so promoting it.
All right, thank you so much. Are there any questions?
Hi. So I was wondering what you expect from the future of OT security, especially because you mentioned a lot of hardware is not replaceable, and a lot of those hardware have open vulnerabilities that hackers will exploit. But we're not going to see replacements in the coming 10 years.
Yeah, at least, first of all, it's humans who are managing the OT and supply chain. So of course, nothing can be patched in one day. We have vulnerability which are never just discovered. So human awareness is needed. Insider attack should not be there. We should maintain identity and access management for the vendors. We should segment our network. These are some basic things we can do in case we are not able to replace those hardware or not able to patch. But of course, in future, let's say a small loophole in whole network can lead to a big attack. We should not take any risk very lightly. We should handle each small risk to be considered as like it can lead to a big risk. But yes, there are levels of defense we can do at least, which is on network level or identity access level, patch management as quickly as possible. But yes, in future we have to replace or modify the firmware or patch it. And this is just starting. The AI-driven attacks on the OT are still coming. That will be more dangerous. Blockchain are also being impacted into OT. It's positive and negative. So yeah, since the technology is evolving, the OT should also adopt that.
Any more question? All right. Thank you, Jay. Thanks a lot.
Hallo. Hi. Ja, mag ook zonder hoor, maar ik denk niet dat we... Ja. Even kijken. Zo, gaat het gelijk? Zit het een beetje? Ja, het zit er nu gewoon in. Ja, dat moet helemaal goed zijn. Oh. Dat is niet aangevraagd bij mij in ieder geval.
Nee, het zou gewoon moeten zijn.
Oh. Nee, ik heb in de andere zaal willen we dan waarschijnlijk heen, maar ik weet niet hoe... Oké, maar even...
Test 1, 2.
Yeah, you should put this one in your phone. I think don't use these two techniques. Leave them empty. Okay. Put it in your back pocket. Yeah, you need to have it smooth. Give me your wallet. It's fine. Oh shit! Oh shit! You don't have one right there. One day you're walking in the park waiting for business and then they take your house.
Nee, per audio. Kan mij even hiernaast vragen, die is heel goed, die is wel beter met apples.
Oh yeah. Yeah, he's going.
Ik heb een Apple die wil.
USB-C to HDMI. That's okay. Number 3. Oh, fine. Have them share slides with you or something?
Okay, ladies and gentlemen, the next talk is about tracking the adversaries in the middle, or AITM, and we have Lex Krielars on the stage.
Hi, welcome. My name is Lex Krielars, and my normal job title is absolutely too boring to mention, so I'm going to call myself a dark web tour guide for now. What I mostly do is storytelling. So I have a story here for you today, and this is a story about adversaries in the middle, or AITM, which is a thing that has exploded a lot in the past. With the adoption of MFA, multi-factor authentication, threat actors have been trying to find ways around it. It used to be easy. They would steal your username, they would steal your password, and then ta-da, we would have access to your account and your bank account and this and that. And then we started deploying this very annoying two-factor authentication. You would get a text message with a code or a TOTP or something like that, and then, we have thwarted all the threat actors. And then the threat actors thought, we're going to think about something that we can thwart you back, and it's the infinite cat and mouse game between us and them. So how does it normally work when you log into, I don't know, Microsoft or Google or whatever? You are on your laptop, you go to that particular website, you fill in your username or password, you get a request for a two-factor authentication, and then that website sends you a session token. And then with that session token, you have logged in, and that session token is actually kind of powerful. I'll explain later. Now, adversary in the middle is the same thing, except the bad guys, they inject themselves in the middle of this stream. So when you, as the victim, think you are logging into the official Amazon, Google, Microsoft, SharePoint, whatever website, you're actually on a fake website. And the fake website is run by the threat actor. And then they proxy your login request to the actual website, and then the actual website says, hey, I need a two-factor authentication code. And then the threat actor proxies that back to you. And then you, of course, I need to give my two-factor authentication because I am on the legitimate website. You are not. And then you fill that in, and then the adversary says, well, thank you. I can now log in as you with your username and your password and your 2FA code, and I'm going to steal your session token. And now with that session token, I can authorize myself at that website as you. And the additional downside of having your session token stolen is that it is usually a long-lived token. By long-lived, I mean 30 days, 90 days, not 2 years. And that if you reset your password or something like that, the session token is still active in most cases. So you think, they may have stolen my username and password, but I'll just reset my password and then I am safe again. Wrong. So now we know a bit about the adversary in the middle. How does this live in the cyber realm domain? Well, it's mostly actually phishing as a service. There are a lot of cyber criminals out there who offer this to other cyber criminals because, I mean, if you can't make money off of unsuspecting victims out there in the world, then you can always make money off of other criminals, right? So they offer this as a service to other people. There we go. And basically the entire pyramid from script kiddies to cyber criminals to financially motivated to nation state allied to nation state funded to actual nation states use this model in order to gain access to credentials and accounts of people that they want to get access to. Some of these are pretty professionally developed. Some of these are not so professionally developed, and you can just smell the ChatGPT through the code base. But the threat actors use adversary in the middle attacks for a variety of reasons. Sometimes it's just to gain access to somebody's account. It can be for business email compromise. Hey, I'm going to phish you. And then when I've successfully phished you, I have access to your email account, then I'm going to email you because you know that guy, you trust that guy. Oh, I got an email from him. Oh, of course I'm going to click this link. And then I have access to your account. And then I'm going to send him an email, and you know that guy. And then before you know it, I have all your email accounts, and you have just trusted the guy or gal that you normally have contact with. And then, ta-da, I have an entire web of email accounts that I now have access to with your other credentials, your mailboxes, and so and so and so. And from there, I can do all kinds of bad things, trademark. Having access to your account, especially if it's your corporate account, allows me to do a lot of data exfiltration. I can steal data from there, things like ransomware attacks and things like that. Or I can just sell the account because, hey, you work at this and that company, and there might be somebody out there that wants to target that company and will buy the initial access from me, the session token or just the credentials or whatnot, for a nice sum of money, and then they can do whatever they want, and I don't want to know about it, and, you know, Bob's your uncle, goodbye. Okay, a lot of threat actors want to do phishing, but don't know how to do phishing, or at least not technically. So what they do is they go out and buy phishing kits. And these phishing kits, there's quite a few of them now. These are the ones that we have eyes on. The ones that are in bold, so Tycoon, Kratos, Mamba, Naked Pages, Saiga, and Flowerstorm, are the ones that we have pretty much automated the entire process for ingesting threat intelligence around the deployment of these phishing kits. And the other ones, Evil Proxy, Evil Nginx, and so on, are the ones that we still do manually because they change things, they try to stay under the radar, and so and so and so. But we look at these phishing kits because they have commonalities in the way that they are being deployed, in the way that they work, and by finding these unique identifiers, it helps us when scanning the internet and when being provided submissions of phishing sites and say, hey, this one is actually from Tycoon, or this one is actually from so-and-so. And then we build signatures and detection logic on that and then help protect our customers. So, but before we started doing all that, we asked ourselves, should we even do this? Because there is actually quite a lot of threat intelligence around adversary in the middle attacks already out there. Sequoia, Media News, or a few companies, Helsezegt, NFCert in Norway. They do a lot of work around adversary in the middle, these phishing kits. And is it really important that we also start to do our own research? Well, yes. Why? It is one of the most common attack vectors that we see in our security operations center. Even though there are very many ways to protect yourselves against adversary middle attacks now, it's still very easy to do, it's very cheap to do for a threat actor, and it's still very successful, unfortunately. So we still see a lot of them. And given the fact that we have quite a reach as an organization ourselves on sensor data and things like that, we can actually fill in a piece of the pie charts of what all the other organizations might miss. So we complete the picture even more, even though there is already a relatively complete picture. With our information added to it and sharing with everybody, we make an even more complete picture. So how do we do this? How do we, let's get into the nitty-gritty. We have something called urlquery.net. You might have heard of something called urlscan.io. urlquery.net is basically the same, but not exactly the same. It was developed by our log team. Actually, one guy, Lars Olav. Let's give it up for Lars. Hey, well done, Lars. Hey! Yeah, I'm going to show him this on YouTube. He'll be happy. And what does it do? Well, it analyzes URLs, just like URL scan does. You put it in a URL, the URL gets sandboxed, and before you know, you have a full report around this website and a suspiciousness score of is this website legit or is this website absolutely not legit. The difference with URL scan, there's a few things. URL query dumps the entire website and the entire JavaScript engine and all the resources that belong to that page for analysis. And we run it through a wide range of sandboxes in order to say, hey, is this website actually legit or not? And when people submit phishing websites from, for instance, Tycoon, 2FA, and things like that, we use the markers that come from there and the indicators of compromise to feed that into our threat intelligence. So the difference between URL scan and urlquery.net is there is a pro version for URL scan. There's a free version that you can use, but if you want to disable internet access or make the endpoint that you come out of a different country and things like that, you have to get the pro subscription and then you have to pay. This one's entirely free. So the next time you want to submit a website to URL scan, I'm not saying that you should skip URL scan, but like the meme says, why not both? It's free, so give it a go and see if this scratches a different need that you might not get with a URL scan. It comes with an API, so if you want to integrate it in your workflow and want to automate your submissions, you can. Also, that is free for use. And what do we use it for? Well, we use it and the information that we get from there for threat hunting. We automatically harvest IOCs from URL query. And we use it for something called secure DNS. And you're like, what's secure DNS? Well, Secure DNS is another free service that we have. It's these 4 IP addresses. They do what you expect them to do. They DNS your traffic and they translate URLs into IP addresses. But if there is a DNS request that is malicious, according to our threat intelligence, we sinkhole it. You can use this by simply changing the DNS servers on your whatever home router at your grandpa and grandma's parents, or your parents if they're like, you know, not exactly technically illiterate, and you're kind of worried that they might click on a phishing link, and you're tired of them calling you up every time saying that, is this email for real? Do I really need to pay? And then you're like, no, mom, you don't need to pay the IRS again. It's this is phishing. So what I've done is, at my parents and grandparents, put these IP addresses as their DNS server, so I know that when they go to something that is slightly less legitimate, they get a blank website, they get a sinkhole page explaining, they don't understand, then they call me, and then I know, aha, okay, it was sinkhole because of our secure service. Non-DNSSEC and DNSSEC versions are available, free service, knock yourself out. So, example. We'll take one of these phishing kit websites. This one is from Tycoon2FA, so it was generated with that particular phishing kit. And what does that look like? Well, as a user, it looks kind of like this. You get an email or text message, whatever. They lure you to one of these landing pages, and then you're like, oh, a document. Oh, I need to pay. Oh, I need to whatever. And then you click. Okay. So what you need to know is that with most of these phishing kits, as you start typing, everything that you type is automatically sent that way. You don't have to hit submit, especially if you end up in filling your credit card here, and you fill in your credit card, and you fill in your CVV code and your expiration date, and then you're like, oh, wait, this is fake, this is a fake site. Oh, just in time, I didn't click submit. You're already too late. It was already sent to their backend. Remember that very handy password manager that you have with autofill and, you know, credit card information in there that it just like fills in your credit card information at the push of a button, or sometimes even automatically? Yeah. Gone. Okay, so these guys have been around since 2023. They're one of the biggest ones, which is why we're using them as an example here. And what you need to know is that this is actually a three-stage thing. There is a landing page, there is the backend that is for the threat actor, and there is then a service page, which is the checker, and then the stealer page. So this is not one website where everything happens. There's actually 1, 2, and 3 steps included here. They use a user agent of Axios, and the target resource that they have is home office in order to, you know, flow away in the traffic as you analyze it. So like, oh, office, home, sure, fine, whatever. But for us, these are things that we use in our signature detection in order to find these guys. So, one of the advantages of URL query is, like I said, we dump the entire JavaScript engine and all the resources, so we have all the code that belongs with that particular website. Here's a small part of the code, because part of it is that you get a turnstile challenge. It's this one. You've probably seen it a million times. Prove that you're a human. Prove that you're not a robot. What check marks don't look like a traffic light, or you know, those types of things. There is an invisible ID on the website called AN7, and it renders the CAPTCHA into that ID, making it visible. And then in the code, there is obfuscation. And obfuscation in this case is writing backwards. You can see it here in the code, for instance. You can see RXP, which is expired backwards, or error backwards. So it's not really obfuscation, but you know, they're just trying to make it one layer more difficult, that when you do your regular expressions through this for these types of keywords, that you don't find it. So yeah, you see here a couple of examples of those backwards strings. And then they join them, and then they reverse them, and then you get the original word again. Language. Timeout. Okay. So, if that is successful, you move on to the checker function, which is the next one, because they actually check if you're like a legitimate, if you are phishable, is what they want to check. So, in the checker, they create a form with all the information that you have put in there, and then they post it to a specific URL, but that only happens after they check that this checker domain is actually reachable. If you can reach that, because yeah, it's not being blocked by any type of threat intel or a smart firewall or something like that, can you reach that? Yeah, okay, then post the information and check if it was successful or if it was an error. If you cannot reach their checker domain, they just dump you to Amazon.com, they say go do your Christmas shopping and then buy. So if you've ever gone to a website, expected one website and then ended up on Amazon, you're like, how did I end up in Amazon? Probably something like this happened. So the landing page that you get sent to from the phishing mail or link or whatever is one thing. But this checker domain is actually a lot more valuable from a threat intelligence perspective, because those landing pages, they just create them and dump them and create them and dump them like non-stop. So if you think like, haha, I have a domain name for this landing page, I'm going to put this in my threat intelligence, and everybody that goes to this page will know that it's a phishing. It's too late. It's already gone. And they've already created a new one 5 minutes later with a different name. So those landing pages, they just come and go non-stop. But those checker domains, those are a lot more valuable. Those are not being created and destroyed every 5 minutes. Those stick around for a while. So having those checker domains and having those in your threat intelligence feeds is actually kind of valuable. Now, when they actually go to steal the credentials, we go to the stealer domain. And the formatted args that you have, those are the credentials that you have sent in there. And they are posted to this hard-coded domain over here. And now that's interesting to happen. That's interesting to know, and that's interesting to have, because those domain names, they stick around for a while, and those are valuable to have in your threat intel. Like I said, those landing pages, nobody cares, but the checker and stealer domains, those are interesting. So those we keep, and those we use in our threat intelligence to determine if users, customers, victims have visited that particular website or not. So they check if it's a reply, then they decrypt the formatted args that came in, and then they grab the session, and then when we see this happening in the traffic of our customers, we know what time it is, we know it's too late, and we can fire up the response engine and start with the reset passwords, revoke session tokens, and et cetera, et cetera, et cetera. So, what do we do with this data that we get from URL query? Well, we use this to write detection logic, Yara rules in this case mostly. Here's a couple of examples. Variables when it comes to parts of the domain name, the formatted args that happen. If you go back here, you see those formatted args. They come back here as well. The plus rand route, which is over here. So we use things that we see in the code as variables in Yara rule signatures to detect traffic that matches these things. And of course, the bad guys, they tweak and tune, and then we have to tweak and tune as well in order to stay up to date, so that infinite cat and mouse game keeps going up. But when it works, and then you get results like this, where you don't know that there is a new checker or stealer domain, but based on the Yara rules you have and the traffic you've seen, you're like, hey, similar traffic to a new domain that we hadn't seen yet. And now we found that new stealer and or checker domain because of the signatures in the traffic, and not so much the fact that we have seen the website and know that it is actually a stealer or a checker domain. So that's nice. Now, we track all this traffic as much as we can, and we visualize that in some graphs. Why? Very simply because the bad guys don't give us a phone call and tell us that, hey, we updated our code or this or that, so you also need to update your detection logic. Shit, my job would be a lot easier if they did that. But they don't, so we need to stay on the up and up by tracking them and seeing that, oh wait, certain things are going like flatline. They might have changed things, which is our input moment to go in, dig in again, find the latest version of their code base and see if they have made changes to the way that they send their codes, send their credentials to where, from where, etc. And if we need to revise our signature rules in order to catch them again. So yes, infinite cat and mouse game. Okay, so threat intelligence. Why are we doing all this? Threat intel, as a thing, is a pyramid. At the bottom you have data in its rawest form, IP addresses, URLs, things like that. But they don't mean anything until you process them into information, which is data but in processed form. And then at the top, when you actually say, haha, now I have information, now I'm going to do something with that information, now we speak of intelligence. So we want intelligence, not for the sake of intelligence, but we want intelligence for the sake of making educated decisions around the way that we deal with these phishing kits and how we work around them and how we continuously keep detecting them. And what we need to keep in mind is that when we build this threat intel, who do we do it for? I mean, we do it mainly for the security analysts that operate our SOC, because they see all the alerts incoming. They need to do triage and analysis on that, correlate with existing and outside threat intel, and then eventually make that decision. Yes, this is a true positive. No, this is a false positive. It goes into the bin, and then next. Secondary, we do this for our customers, and we do it for the detection engineers, because the detection engineers need to know what's going on, so that when new versions of these phishing kits come out, that they can modify, create, update, lifecycle, whatever, the detection logic that they already have in order to stay ahead of the curve, so that future phishing kits can also be detected. So we need to make sure that this process is in line with the needs of the people that we do it for, and not just, you know, why are you doing it? Because we can. I mean, it's also a valid reason, but it's good if it has a second real reason that supports the security processes that we have. So, kind of already mentioned this. For the SOC analyst, what does data mean? Data for them would be a list of IP addresses and domains that are, for instance, those phishing domains from Tycoon to FA. But if I just give them a list of IP addresses and URLs, they're going to be like, what's this? So in order for them to understand what it is that they're looking at, it needs context. So if I give them the list and say, hey, these are phishing websites, and these are the checker and sealer domains, then suddenly for them it's information. And then on that, we can say, with this information, you can make educated guesses around the incidents and alerts that you are triaging. Then it becomes intelligence, and that helps them on the split-minute decision when it comes to, is this a true positive or is this a false positive? And if this is a true positive, what should I do? Reset password of the user, revoke session tokens, reinforce MFA enrollment, and things like that. And then for the detection engineer, they zoom out and they say, well, we're catching these phishing kits today, but they might change it tomorrow. They might change their code base. They might change the way that they're doing business now and sending information back and forth. And we need to make sure that our signatures are wide enough to catch it when they make small modifications to their code base, but not too wide that we get a lot of false positive. And they need to be narrow enough that we find them, but not so narrow that we miss any true positives. So they need that information in order to do their job. Now, the best thing, of course, is to make sure that you are not exploitable in the first place. So when it comes to adversary in the middle attacks, there are very good ways out there to not be exploitable. Most organizations are in Azure in some way or shape or form. So conditional access policies have loads of capabilities of saying that, oh, users logging in with a different user agent for the first time from a location that they've never logged in from, and so and so and so. I mean, it happens after the fact. The user has already been phished and their credentials have been compromised. And the threat actor is then using those credentials from a different location, different user agent, and so and so and so. So you're still going to have to act, but at least conditional access policies will kick the threat actor out, and then from there you won't have to deal with more compromise and more data exfiltration and so and so. Now, together with making sure that you only allow compliant devices and then risk-based policies will make it quite difficult for threat actors to successfully exploit credentials if the user has been phished. And if that doesn't work, I know they're not the cheapest around, but you have FIDO2 passkeys, the UB keys, and things like that. If only for your most sensitive employees, that if they get compromised, you're like really up shit creek without a paddle, would also be a suitable solution in order to make sure that they become relatively hardened to being phished. And then it becomes a bit of a math game, like how much time are you spending on, even if you've gotten the process down to a T, and you can do it like click, 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 okay, this user has been uncompromised, we've revoked and this and that and so and so and so. How much time is that taking you? Because even if it takes you only 10 minutes, if it's happening 40 times a week, that's still 400 minutes. And compare that to a solution with a bunch of FIDO keys, or actually setting up proper conditional access policies, or one of the other ways to do adversary middle mitigation, might eventually actually be worth it. And with that, I would like to say thank you. I hope that this was entertaining and or informational. And if you have any feedback, please scan the QR code. It is not a phishing website, I promise. And if not, then come find me after the show, and if you have any questions, or now.
Very insightful talk. Thank you, Lex. Are there any questions?
My presentation was so clear, there are no questions.
All right. Then, yeah. Thank you so much, Lex.
Yeah, you're welcome. Enjoy today.
Thank you.
Gelukkig dat het toch nog goed gegaan is met die andere.
It's working.
All right.
Are we good? Okay, perfect.
We have Marvin and Goma here, and he's going to talk about EDR blind spots and exploits, which which is another cool and technical talk again. And yeah, the floor is yours.
All right, awesome. Wow, it's loud. Great. All right, good afternoon, everyone. Good afternoon. I live in Sweden, and the Nordic people are not very conversational. So I was told the Dutch are a little bit more open, so please show it to me. Good afternoon. Afternoon, perfect. Say hi to the person next to you. Just check if they're okay. I know it's a little bit weird, but I like to keep stuff interactive. Just check on the person. Even if you don't know them, just say you're having a good time, just check with them, just make sure everyone is good. I know it's after lunch sessions, so it tends to be a little bit, there's the food coma that kicks in as well, right? All right, welcome to my talk. My talk is entitled Catch Me If You Can, How Attackers Outsmart EDR2s. How many of us work with endpoint security? All right, you know what? I know there's gonna be a lot of questions today. It's almost the entire room, right? Okay. So we do know that EDR2s have evolved. They've just developed. They're doing amazing stuff in our environments. And they've become a big target by attackers or for attackers, right? So that's going to be a little bit of my focus of my talk today. Basically, what are attackers doing to evade those EDR2s? A little bit about myself. My name is Marvin Ngoma. I work for Elastic. I'm a principal security specialist. I'm part of the global security specialist team. I'm passionate about security operations and intelligence. I've been with Elastic for about 4.5 years now, previously with IBM in the Nordics again, where I did security intelligence and operations consulting. So I just love everything around intelligence and operations and basically helping organizations develop their security operations capabilities. I know cybersecurity people are very obsessed with tech, but I also have hobbies. I love to travel, I love seafood. I'm a Manchester United fan, don't laugh. I play bass guitar as well, and I like to explore new hobbies as well. If anyone wants to connect on LinkedIn, those are my details in that sense. So what agenda do I have for you today? So I'll look at basically how EDR2s work. We know they're there to stop malware from running in our environments, but we'll just take a few steps back and just go a little bit into the internals of how EDR basically works. And then we'll go into the gist of the talk. How do attackers basically try to evade the capabilities of EDR? I'll try to touch on some real case studies, time allowing, and then I'll close it off by just giving some practical guidelines on how you can basically do defenses. Who recognizes this wave? This is from math and physics and sciences. What wave is this? Is it sine or cosine? Is it sine or cosine? Now I see who was paying attention in math class. It's a cosine. It starts half phase, right? Yeah, so it's a cosine. It's got nothing to do with my talk, except for the fact that you might find this content to be very technical, some of you, and you might find this content to be very light for some of you that work with EDR2s. I usually get mixed feedback about this talk. Some people go like, oh, it was too technical. Some people go like, oh my God, we're expecting a little bit more, So it's going to be like that. Some parts are going to be very technical. Some parts are going to be light. Okay, the reality today is there's so many abbreviations, acronyms, and names within the endpoint security space, right? So historically, we've called these tools AV, antivirus. If you talk to certain vendors, they'll call this next generation antivirus. Some people call them endpoint protection platforms. At Elastic, we call this EDR, so basically endpoint detection and response. Some other vendor friends of ours came up with a new tag called XDR, and it sometimes gets a bit confusing. But let's be honest. At the end of the day, all we're trying to do is find malware in our environments, right? So that's what I think about all these names in the industry today. My focus is going to be on EDR because I think we should just call it EDR from that perspective. Okay, so in a nutshell, we've grown so accustomed to antivirus, right? So antivirus has gone through a lot of innovation, if we can call it that, and that's been driven by what we're seeing in the endpoint security space from a threat point of view, right? So ransomware has been on the rise. We've seen botnets, we've seen polymorphic malware, and different malware family types as well, right? So it drove AV2s to go beyond signature detections, right? We needed to get to a place where we can also identify zero-day kind of stuff. So we introduced heuristics and behavior analytics on the endpoint. we introduced machine learning, endpoint-centric machine learning kind of capability. And then some EDR vendors or antivirus vendors also have what we call HIDs and HIPs, so host-based intrusion detection systems and host-based intrusion prevention systems as well as firewalls. But then, those of you that work in the endpoint security space, you were like, nah, this is not enough, right? We need a little bit more. So we're looking for anti-malware and exploit prevention capabilities, right? And then also we're looking for telemetry, because we want that context. It's great to get an alert that malware fired, but we want a little bit more context in terms of what is the telemetry that is surrounding a very malicious activity. So this is my conclusion of what EDR is supposed to be. Your EDR2 is supposed to give you anti-malware capability, telemetry collection capability, and then ultimately, from an incident response point of view, you want to do that response action. So let's look at the components that make up an EDR. There's primarily 3 components. The first one is the agent itself, the piece of software that you install on the endpoint. So basically, the agent controls and consumes data from multiple sensors. A sensor is something that is basically just sensing the stuff that's going on, and then it's picking up hints on what's really going on the endpoint itself. The agent is also responsible for things such as alerting, so it's got detection capability or prevention capability, blocking, and deception capability as well, right? Then we talk about sensors. So sensors are just basically there to observe activity that is happening on the endpoint. So I hope you're beginning to get the gist of it, right? So the agent is what we install on the endpoint. There's a sensor component as part of the agent as well. It's sensing activity. It's a super fast processor. And then the agent has got inbuilt logic that is using that activity to see what is malicious and non-malicious in that sense. And then ultimately, we get the telemetry itself. So this is the raw data produced by a sensor or the actual endpoint itself. When you log in, there's an activity that goes on. It's an activity, right? So there's a sensor that's tracking that as well. When new processes are coming on the endpoint, that's telemetry, and the sensor is sensing that activity. When you create a new WAD file on the endpoint, that is also an activity, and the sensor is sensing all these things, and then reporting it to the agent itself. Key to the telemetry is there has to be completeness in the data that we're collecting on the endpoints themselves. What do we mean by completeness? If we're tracking file activities, you want to track the entire life cycle, right? From file creation to the file changes that happen to a file. Ultimately, when the file is deleted, you want to be tracking that completeness of the data as well. So we're talking file activities. It could be a process. It could be a network communication. But it has to be telemetry that is complete in terms of the story that it's telling you. So this is where now we begin to go a little bit into the weeds. I hope I don't lose people here. Some people are already familiar with this type of architecture. But basically, this is the basic composition of an EDR agent, right? So if I start on the left-hand side, you have what we call a static scanner, right? So this is basically scanning the binary files. So the services that are running on, if we're talking from a Windows perspective. By the way, this talk is going to focus on Windows, but there's equivalent implementations on other operating systems as well. But we do know that Windows is one of the most common operating systems in the world, so I'll stick to Windows in that sense. So you've got the static scanner, right? So there's portable executables on our endpoints that execute, and you just basically want to do scanning of those PE files. And then when we come in the middle, there's what's called a kernel mod driver. So we do know that on the endpoint, there's a user space, there's a kernel space as well. And most EDR tools also reside in the kernel in the form of a kernel driver. Some people love that, some people don't love that. It's a big debate currently whether we should be doing it in that way. I'm a huge fan of having EDRs as part of the kernel drivers. Reason being, they give you raw telemetry. They give you that visibility you wouldn't really get in the user space as well. So we're getting a lot of telemetry, registry activity, memory activity as well, and then we're sending that into the agent service itself. And then you've got a hook DLL, and I'll expand on what that is, but there's a whole lot of telemetry that we're collecting. Some EDR vendors extend this basic EDR architecture. So they give you us the static scanners, but they'll also give you what we call a file engine. It's just going to be monitoring file activity on the file system. And then there's also filtering that happens in the context of the memory itself, right? So everything that is running in memory, the processes, the threads, and associated memory information, that is also being tracked as well. Some EDR2s also give you a network engine. So every network activity that is going on the endpoint is going to be tracked from that perspective. And then finally, some EDR2s also extend this with emulators or sandboxes. So if the EDR2 is not so sure whether a certain process is malicious or not, it will execute it in a little sandbox, do the malware analysis, and then make a decision whether to allow that to continue or not. So again, different vendors give you different flavors in terms of capabilities. So far, so good? You look so serious, you're scaring me. Or it's either you're paying so much attention, we'll find out at the end. Okay, so we talked about hooking DLLs, right? So this is a nice scenario of what really happens on the endpoint. There's something that is going on in the user space. And maybe I should have shown a much simpler example, but also this is simple for those of you that work with these tools. Let's take a simple example where you want to create a Word document on your laptop, right? You're creating a file. Now, a file needs to be mapped to the file system as well. So you're doing that in the user space, but for you to create a file, you need permission from the kernel, right? So you still need to make a call to the kernel to say, hey, I'm creating a Word document. So it's user land making some calls, system calls into the kernel space, and what most EDR2s will do, or AV2s, is basically they'll do a man in the middle and basically do a hook. So whatever parameters you're sending into the kernel, whatever functions you're calling and the parameters that you're sending, they'll do a hook, and then also monitor for the responses that come from the kernel. And if there's malicious intent, basically this is where they'll stop it. So we talked about telemetry collection. I work for Elastic. I'm not here to market Elastic, but we also collect quite a lot of telemetry on our EDR2. There's a nice project on GitHub. It's called EDR Telemetry Project. How many are familiar with it? Okay, about half the audience. That's really good. So if you're wondering, hey, the EDR2s that we have on the market, what kind of telemetry do they present you with? You can check out that project on GitHub. But yeah, different vendors give you different levels of visibility, and this telemetry also has an impact in terms of the anti-malware capabilities that the EDR gives you. So we've looked at the basic composition of an agent. We've looked at the functionality of an EDR agent, right? But we also see that for a long time, attackers have also been coming for these tools, right? And basically, they adapt faster than we do. So it's amazing we're innovating machine learning, endpoint-centric machine learning, heuristics, and all these juicy things. But attackers are always trying to find ways on how to evade the EDR. And it's become a powerful tool as well, and they know it, right? So now the focus is not to attack you only, but to disable the functionality of the EDR itself. So the way I look at EDR evasion, I like to classify it in two categories. The first one is the old way of doing it. I think most vendors are now akin to these techniques. I think most vendors can pick up on this. The first one is on-disk evasion. So malware is just basically software, right? It's code that runs on our endpoints. It needs to find its way on our endpoints, right? So in the past, evaders used packers. So this is where they really compress the file in such a way that it makes it hard to do analysis on that file and determine whether it's malicious or not. Then they went into the whole obfuscation space as well, basically trying to hide the code that is running within the malware files. And then they use cryptors as well. But today, most of the EDR2s are able to identify on-disk evasion. The next one is in-memory or fileless evasion. What does this mean? So basically, attackers know that the services that we're running on our endpoints that we trust, especially on Windows as well, there's so many DLL files we trust, there's so many services behind some of these DLLs, and they're going for those things that ideally we tag as normal traffic or as normal executions on the endpoints. And mostly, they're doing this in memory, right? So going directly in memory without leaving trace on disk as well. A more modern lens to look at EDR evasion basically looks at three aspects, right? So we're looking at blinding, we're looking at blocking, and we're looking at hiding. What does this mean? So the attackers will first aim to do blinding, right? So with blinding, they're looking to stop or tamper with the sensors so activity isn't observed. So if you remember what we defined an EDR to be, one of the components was the sensor. It's sensing activity that is going on the endpoint. And then the agent has got that logic based on the telemetry it's collecting from the sensor to make a call, right? Are these activities malicious or are they non-malicious in that sense? But then if the sensor is not creating the telemetry, the prevention capability of the EDR is not going to work. So one of the things they try to do is to do the blinding, so the EDR agent does not really observe the data. The other aspect is blocking, right? So yes, telemetry is being generated, but then that telemetry is not basically reaching the analysis pipeline. And again, it's dependent on where your EDR logic resides from an anti-malware perspective as well. And ultimately, there's hiding as well. Hiding is where, again, those services and the stuff that we trust on our endpoints is used for blending in, right? So the attackers still execute their shellcode, but they just blend in with those things that we're accustomed to on our endpoints. So far, so good, I hope, okay? You all look too serious. I'm the only one smiling. Okay, another way to look at EDR evasion is attackers will also look at, hey, how does the configuration of your EDR operate, right? What are the settings? And then is there loopholes that can be exploited in the configuration of the EDR? We've heard of agent tampering. Attackers come in, they just look at how basically you deploy your EDR, and then they take certain steps to basically go for that configuration. And then there's also perceptual, right? You alter what the telemetry and the sensors are actually seeing, right? It could be some poisoning of the telemetry, or it just could be basically changing that perception. And then there's the logical aspect. So if we trace this back to the DLL hooking, so you look at the user space and the kernel space, we said most EDR tools would do a hooking and then intercept the communication and look out for malicious activities, right? So there could be a logical evasion where the attackers run things in the user space and then they just bypass the hooking, right? So that's one way of doing a logical aspect. The last one is classification. So we said the agent is the one that's got anti-malware capabilities. It's the one that makes the call. Is something malicious or not? Now, if the attacker can be so smart to evade your detection logic, then they find the leeway in. Because again, they're blending in and they're intercepting some of those configurations. So let's look at the evaders toolkit. What are the different ways that attackers are doing evasion today? So the first one is user mode hook evasion. We'll touch on that in a bit. And then there's ETW and AMSI tampering, right? So ETW on Windows is event tracing with Windows. I hope people are familiar with that. And AMSI is just basically the anti-malware scanning interface. So Microsoft, on the Windows operating system, because they know there's a lot of EDR vendors out there, they've actually made it super easy for you to bring your EDR as a vendor and then make it work on Windows as well. One of the interfaces they give you is the anti-malware scanning interface. So attackers basically try to tamper with that interface, and like we've already established, they try to do memory-only executions, and then there's low bin abuse as well, so leaving off the land binaries. And then ultimately, and this we've seen become very common in the recent months in this part of the world, they do kernel and driver misuse. So bring your own vulnerable driver in that sense, and we'll touch a little bit on that. So far, so good? Easy to follow? Okay? All right. So the first one, we saw hook DLLs and how they operate on the EDRs, right? So basically, again, I'm just creating a Google Doc file. I want it to be registered on the file system. My EDR will do the hooking. It will intercept the calls and see if I'm trying to do something malicious, if I've attached malicious macros in that document or not, and things like that, right? So that's where it happens. So the EDR observes API calls, but ultimately, attackers will bypass the hooks by doing direct operating system calls, right? So instead of their shellcode or the payload going through this hooking, basically they implement techniques where they actually do a bypass or they do a clean API restoration. So they do something malicious and then quickly clean it up before the EDR actually picks on it. So this reduces or removes that user level visibility, and ultimately they do bypass that hooking DLL. A lot of EDR vendors have moved away from hook DLLs, and they're using different implementations for their EDRs. The next toolkit that we talked about is event tracing with Windows and AMSI tempering, right? So with this technique, basically, so how many are familiar with ETW, event tracing for Windows? Okay, so this is great, right? So we've already established that the agent has got a sensor which senses activity. In addition to sensing telemetry on the endpoint, most EDR vendors also depend on Windows itself and the events that the operating system creates for you. So Windows provides you with so many channels for different types of data, different type of activity that is being done on the operating system itself, and most EDR vendors will consume that telemetry as part of the logic for the anti-malware as well, right? And then the AMSI, the anti-malware scanning interface, basically inspects script content, right? So we do know that a lot of malware is in the form of scripts as well. Before they execute, you can actually intercept them at kernel level in the AMSI as well. And we see that attackers try to disable or patch these components, right? So either they'll patch the ETW, ideally it stops creating this telemetry. That means you're not really getting the telemetry that you need for your anti-malware capabilities as well. So this leads to significant loss of script and event telemetry. So you can't really see what the scripts are doing on your endpoints. You can't really see any telemetry coming from the operating system itself. This is, there's a nice article and I do link to it as well. This was early in February of 2025. There were certain attacks. So this is a remote access Trojan that was targeting European organizations. And they basically used new techniques for AMSI and ETW evasion as well. I would recommend it for reading, for further reading. I don't want to go into the details of some of these techniques because again, it might get too technical, so I'll just leave it at a high level. But this is quite a very good read in terms of basically what attackers are doing in that ETW and AMSI tempering space. The next one is memory-only execution. So remember what I said, there's two categories. Attackers can write files to disk and then go on to try to achieve their objective, or they can actually go straight into memory. So there's certain things that are executing in memory, and they try to find themselves executing in the context of those processes. And ideally, those are processes that we've come to trust. So we do know that code runs entirely from memory with no on-disk artifacts. And then some of the techniques that attackers are using or employing is reflective loading, injection, and process hollowing. I will not go through all three, but I'll just touch on two of them. The first one is the PE injection, right? The portable executable, the .exe files that we have on Windows. So how do attackers come for those executables that we've come to trust, right? So the malware can copy itself or its malicious code, the shell code, into an existing open process and cause it to execute, right? So basically there's 4 steps. So there's a process that we trust, it's executing in memory. The first thing that I'll do is open that target process. There's certain cores on the operating system that Windows supports. Open process is one of them. The second step that the attacker takes is to allocate a chunk of memory in the context of the executing process. And then ultimately, the attacker writes their payload into that memory space. So if you're doing process monitoring, all you're seeing is, hey, there's this executable that it's executing, it's something I'm familiar with, we're all good. But in the context of the actual code it's executing, the attacker actually has managed to infuse their shellcode. Does this make sense? Okay, basic stuff for some people, I know that. And then ultimately what you want to do is create a new thread of execution, right, in the remote process to execute your shellcode. So there's a process, and the process we know can spread the tasks through threads as well. So one of the threads is actually going to execute the shellcode, and ultimately the attacker is going to accomplish the objective. So let's do a quick recap, right? So we know that processes execute on an operating system. A process is just basically a file that is executing, right? And when there's that execution that's happening, there's certain states that the process takes. So a process can be in the new state, so you've actually just started executing something on the operating system. It's new, and then it's ready, so meaning there's memory allocated to it, and it's going to be executing, and there's a whole lot of other states as well. So what attackers do is they try to take advantage of these process states, right? And this leads me to what we call the process hollowing. So we looked at injection, right? So injection is a process is executing, and then basically you call an open process, so you've got access to that process. Then you write your shell code in the context of the memory of that executing process, and then you call a thread to execute your shell code. In process hollowing, though, the attackers take a bit of a different approach, right? So the malware basically hollows out legitimate code. So again, this is something that we trust that is executing on the endpoint, and then we overwrite the memory space of the target process with a malicious executable. How does that work? So the steps include you suspend a target process. So remember the states of a process, right? A process can be new, can be ready, can be running. When it's running, it's allocated memory on the operating system, on the endpoint, right? So what happens is the attacker will suspend the target process, and then secondly, it will replace that with a malicious executable image. So the actual process with allocated memory has been suspended, and then you replace the executable image, and finally, the process is resumed. Now, when a legitimate process is resumed, it just continues executing in the context of the memory that was allocated to it. But then when it resumes, it's executing the payload that the attacker planted into the context of that process. Make sense? Okay. All right. The next one I want to talk about is the low bin abuse, right? Where we just abuse trusted tools on the endpoints themselves. So we've already talked about, things that we trust, but what are those things? PowerShell, right? How many people do PowerShell logging from a security perspective? Few hands in the room. It's painful. Let's be honest. Especially if your environment has got developers. The moment you begin to do PowerShell logging and you begin to track malicious patterns, you will get a call from the people doing the CI/CD pipelines. That's just a fact, right? It's annoying, but then again, when you look at it from a blue teaming point of view, attackers are exploiting PowerShell a lot. PowerShell is powerful, but again, it also opens up vectors where you can literally download shellcode from the internet, and then it's going to be run in the context of the memory of PowerShell. So if the only thing that you're doing monitoring on and logging on is PowerShell, sometimes you might not really get context into what PowerShell is executing within its memory space, right? So there's so many documentations on how things that we trust in our operating systems can be abused. And here, basically, contextual analysis is key to detection, right? I know there's a big fighter on how we do monitoring of these things in production, but again, it's really important because attackers are blending in. There's two projects that are very famous at this point, right? One is living off the land, low-base, basically. Anyone familiar with it? Yeah? Wow, it's the entire room. This is impressive. And then there's the Unix version as well. It's called get the fuck off beans. I don't use bad language, but that's what they call it, right? So it's GTFO beans. Very good for Linux as well. There's so many interesting attack vectors that are covered by the binaries that are running on Unix, and basically what we've seen in the wild in terms of attackers using some of these services. So really good projects, please check them out on GitHub and on their websites as well. There's another one that I referenced, we had a meetup yesterday. It's leaving off false positives. Like, you would never guess it, but attackers also leave off false positives, right? So usually when there's false positives in our environment, we just ignore the false positives. We don't turn off those rules that are noisy. We just say, oh yeah, it's always firing an alert, right? And sometimes attackers know you're ignoring those things. So they'll try and blend in using those attack vectors, but that's a story for another day. Okay, finally, we're going to look at kernel and driver misuse. So basically bring your own vulnerable driver. Let's just do a recap, right? So, okay, fine. Firstly, an introduction. When we talk about kernel drivers, so we saw the EDR architecture, right? The EDR today, most of the EDR2s are basically kernel drivers. So Windows allows them. They sign and say, hey, this is legitimate. It's Elastic Agent. We allow it to be run on Windows operating systems. It could be Microsoft Defender, it could be CrowdStrike, whatever you want to use, right? But basically, the EDR of today is that kernel driver, but it has to be signed, right? It has to be something that you trust to really run within the kernel space of your endpoint. With kernel and driver misuse, basically attackers are looking at a way of bringing vulnerable signed drivers to be loaded into your kernel and ultimately get system level privileges and then do the disabling of your EDRs as well. So basically they'll disable, bypass the kernel callbacks, and you're not receiving telemetry, as we've already seen, and then the attacker basically gains freedom to execute whatever they want to execute on the operating system itself. So that EDR either loses deep visibility and detection capability, or sometimes it's fully uninstalled as well. And we've seen real-life stories where EDR tools have been completely wiped out by vulnerable drivers within the kernel space. I like visuals, so this is just a visual. Again, we're looking at the user mode and the kernel mode, right? So we already know that from an operating system perspective. The user mode is where we basically do random standard user activity as well. So you do have user mode drivers, and then there's also a concept of kernel mode drivers. A driver that is residing within the kernel either needs to be signed by Microsoft in most cases, or you need to also have like some sort of PKI, public key infrastructure, where you can also have signed stuff running within the context of the kernel mode itself. So let's look at an example, right? What would an attacker do from a vulnerable driver perspective? So the first step is to always target our users, right? We always say human beings are the weakest link in our organizations, and we see it even with vulnerable drivers. So the initial part is that initial access. Compromised credentials, credential dumping, phishing attacks, those low-hanging things. But ultimately, we know that attackers want to do privilege escalation on our endpoints. So they'll find an initial access point, also try to find a vector where they do a bit of that privilege escalation, and then once they get those privileges, the high privileges, they'll basically do a driver installation. So again, Microsoft are great, but sometimes the model doesn't work, because sometimes they do sign things that actually have vulnerabilities in them. So attackers spend a bit of time just looking at, hey, what is it that Microsoft has signed off to be run on Windows machines that runs with high privileges, right? And this is where the whole patching game comes into the play. But once they identify that vulnerable driver, they'll install it since they've got high privileges from step 2, and then they'll use it. They'll see, hey, what rights does this vulnerable driver have? Can it fully uninstall stuff on the endpoint, or can it actually modify certain kernel structures? So certain drivers are very powerful, vulnerable drivers. They'll fully and totally uninstall the EDR, or actually they'll play around with those structures, and ultimately you want to disable the security controls. Make sense? Okay. Okay, so just a few examples, real life examples. How many are familiar with Neto lock shields? How many have played Neto lock shields? Okay, at least half you've played in lock shields. I love lock shields. If you haven't, try and see if you can play in your team. I know the Netherlands takes part in lock shields as well. We've supported lock shields for the past 4 years, I think. Yeah, about 4 years. We saw this last year. One of the teams we're supporting during lock shields. So for those of you that don't know what lock shields is, NATO member countries have got this cybersecurity exercise, arguably the biggest cyber defense exercise in the world, where they just train member countries to defend your critical infrastructure. So usually it's red team versus blue team. It's real systems, but it's not production systems, right? So we've taken part, and what we saw last year, and this happens in real life as well, we get calls every day as Elastic, attackers were trying to do evasion of our EDR. One of the ways that they try to do this is, you can see all the smileys, at least they were nice enough, it's nothing very disturbing, no, yeah, at least it was just fire icons, but they did log poisoning, right? And they tried to basically stop the telemetry collection of the agent itself. So when we saw this in the exercise, it was a bit worrying and funny as well, but you see that red teamers, and the guy, we had a chat with the guy that did this, he's a red teamer in real life as well, and he said his objective was to actually evade Elastic Defend. Now, you'll meet different red teamers, they're trying to evade other EDR tools as well. But again, this is just a real life example of people that are actually trying to do evasion of EDR tools. There's also another tool that we saw this year in log shields. It's called EDR Silencer. How many are familiar with EDR Silencer? Okay, a few hands in the room. This is another hobby project from another red teamer. But basically, again, what they're just trying to do is that blinding and blocking of telemetry that's being produced by the EDR tools as well. So we're seeing a lot of these things coming up. It's close to home. Attackers are actually trying to disable your EDR. So what can we do in terms of avoiding EDR evasion, right? So the first one is turn on script block and script logging as well. I know this is painful in terms of logging what your scripts are doing, but we need to do it. So log whatever is happening with your PowerShell, log whatever is your VBS scripts are doing in your environment, your bash scripts. We need to have a bit of visibility into what the scripts are doing within our environments, because those are huge vectors that attackers are doing. And then apply Microsoft driver block list updates as well. So it's okay for things to be signed by Microsoft, but also just monitor for, hey, does Microsoft still trust some of these things to run on our endpoints as well? Really, really important. I know it sounds easy on paper, but in reality, it's such a very hard thing to do. And then the other thing is monitor your agent heartbeat. We've seen the crucial part that the agent plays in terms of EDR. You just always want to make sure that your EDR or your agent is always checking in home, right? So it's alive and doing what it's expected to do. And then also we saw that ETW and the AMSI, so the anti-malware scanning interface, the one that scans the scripts, and also the ETW telemetry can be tampered with. So you just want to have temper hands as well. Microsoft are really good with telemetry. So if some of these channels have been disabled or these capabilities have been disabled, there's a way of actually getting event codes that actually give you a hint into that activity happening. And then also you want to baseline and monitor low bin usage, right? So we saw that there's certain binaries and services that run on our endpoints that attackers are going for. So similar to the PowerShell logging, you just want to make sure that you're monitoring some of these aspects. I'll not go so much into all these parts. The third last one is hunting for read, write, and execute allocations and remote threads. And this is in the context of processes, right? So you just want to make sure that your EDR capability can also just basically monitor what are the threads doing, what are processes doing on the endpoints. Are they trying to do certain things in the context of other processes as well? So this is something that a lot of EDR tools are doing, but just make sure that these capabilities are actually turned on as well. Okay, with that, I just want to end it with some recommended reading. This is, how many are familiar with this book, Evading EDR? Matt hand, now you're familiar with it? Okay, few hands. If you're interested in this topic, this is a very good book. I think it's arguably the best book I've seen on evading EDR. There's a lot of references about Elastic, so I like it even more because of that, because I love Elastic. And then also the technical review of this book is one of our VPs within the endpoint security space as well. Really good book, really nice concepts. I urge you to read up on it. There's a lot of public write-ups on ETW and AMSI and driver abuse and agent tampering as well. And then even if you're using another vendor, please check their threat research and also their community blogs, because most of the vendors are actually doing continuous monitoring of what's going on. We have our own Elastic Security Labs as well. There's a lot that we're doing in the EDR evasion space as well. So please have a look at some of the work that we're doing from that perspective. With that, I can say, that's all, folks. Any questions?
Thank you, Marvin. Are there any questions, guys? Yeah.
Okay, all right. No tough questions. Thanks a lot. Thank you. Thank you. Oh, was that a question then? Oh, okay. Damn. I thought I got away with it. Oh my God. No tough questions. They're recording, you know. This is going on YouTube.
So I'm curious what your opinion is on an EDR living in or operating in the user space or kernel space.
I wish I'd put money on it. I knew that would be the first question. Every time I give this talk, that's the question that comes up. So you got the question, right? So should we continue having EDR tools operating in the kernel space, or should we let EDR tools operate within the user space? It's a tough one. I personally, this is my personal opinion, I think we should continue having EDR tools operating in the kernel space. Reason being, it's a no-brainer. It just gives us so much access to easily identify malicious stuff. The user space is such a very unprivileged space. It's not even interesting from an attacker perspective as well, right? Because, I mean, yeah, it's user space, less privileges. There's not so much you can do to change and alter the functioning of the endpoint itself. So again, attackers, if we operate in the user space, attackers always find their way in the kernel space. And if you're in the user space and then in the kernel space, it's so hard to monitor, you know, from a less privileged position monitoring what's so privileged. It's like it's a private party and you're not invited, but the attackers are invited, right? So I do understand the problem now is if we, as EDR vendors, operate in the kernel space, then you need to install us with multiple privileges. So if we are not so good in terms of our own sanity checking and we're abused, we've seen, I think the previous talk or the talk before that, the OT talk, spoke about, the NPM package compromise that's been happening in the past few months. So if you're an EDR vendor and you're using those NPM packages, there's a supply chain attack, and I'm operating in the kernel space of your machines, then I'm bringing a risk to your organization as well. So it's a bit of it's a tricky situation, but ultimately, I think the benefits of operating in the kernel space outweigh the benefits of EDR being in the user space.
I share that opinion, but I'm curious why Microsoft then is pushing the EDR vendors out of the kernel.
Out of the kernel. I've been tracking that as well. I would say, as long as EDR vendors get special treatment, even if we operate in the user space, I don't care what Microsoft do, as long as they still give us access from the user space to get into the telemetry that we need from the kernel space. If they can also have an interface where they provide what we need in the kernel space, in user space, great. But the problem with that is, what's the difference? Right? So there's no difference at the end of the day, right? Because we still need to have that visibility into the kernel space. The beauty with what they're trying to do is, if we are compromised as an EDR, I don't know how they implement this, but they're trying to really minimize what we can do in the kernel space. I don't know. We'll see how it evolves. We blame Microsoft, yes. I know we're recording this, but yes. No, I'm just kidding, but yeah, that's just my opinion on it. Very good question, by the way. All right, any other questions?
More question? Any more?
I was hoping he doesn't raise his hand. I told him yesterday, no questions from you. Okay.
Marlon, thank you for the talk. It was really interesting to listen to. My first question is, I think from my perspective, my EDR, if I install it, should definitely detect any privilege escalation exploitations. What's the problem in doing that? So why still we have these vectors applicable in real-life scenarios?
That's a very good question. I think security is not static. Security is dynamic, right? And then also, one of the things that we tend to usually forget is technology in general is created to create a better experience for the end user. So the focus for me is always going to be innovation before security. And as long as innovation always comes before security, there's always going to be vectors to do things such as privilege escalation. So as EDR vendors, we can catch up as much as we can, but attackers will always find a way in. Because again, tech is a very constantly changing space, and I think privilege escalation will continue, even if we have very good protections in that sense.
Let me clarify.
Okay.
So I think that if we have some unprivileged process which spawned high privileged process, that should be detected.
Detection is, yes, it will be. And this is why I said when you start doing PowerShell logging, it usually causes a lot of noise, especially if you're in an environment with a lot of developers. Because in most times, developers also will be operating in the user space, legitimately also want to do things in the kernel space using PowerShell. When we look at it from a security perspective, we will get that alert. Hey, there's a user that started PowerShell, and it did something in the background that went into a privileged state. So again, it's usability versus cybersecurity in that sense, right? And I don't see that ending. So I think the EDR tools will be able to tag that, but the question is, what's the context of that alert? Is it a true positive? Is it a false positive? If it's a developer doing it, then it's a true positive. But again, I mean, it's a true positive, false positive, but it's a legit thing that they're doing. But then also it could be that another time the attacker does a compromise of the developer and does the very same thing. And that's where it becomes a little bit of a cat and mouse kind of scenario. It's going to be a tough one. And that's why, we talked about this at the meetup, those of you that were there yesterday. There's a lot of context you need to bring into your workflows. Just try to understand, is it a developer? And maybe in real time also just check, hey, are you the one that actually did this in real time? A Slack message or a Teams message from a SOAR perspective as well. But it's a whole topic on its own. But generally speaking, I don't see these things stopping anytime soon.
Okay, thank you. May I ask another question? Yeah, we have time.
Do we have time? Oh, great. 2 minutes.
Next question is, have you observed any time-based attacks? Like, for example, as far as I know, EDR always work with events based on or limited by some time frame. So do you know, let's say, a way how we can still detect those time-based attacks, except using sandbox? Because obviously there we can, how to say that, we can skip those long sleeps, delays, and so on, but can you do that in real time?
That's a good question, a little bit of a tough question, but let me get back to you on that one. From an EDR perspective, it's going to be a bit tough. And that's why for me, it's like, I've met security teams that depend on EDR only. I don't agree with that. I've met security teams that depend on CM only or analytic platforms only. I don't agree with that. I think the two complement themselves. And the reason why I like that is the EDR is going to do on-endpoint prevention and stop things before they actually achieve their objective. But you still need that telemetry that I talked about ending in your analytic platform, because that's where now you can build nice detections that are able to detect things such as that. Because most telemetry also comes with timestamps, right? The original timestamp on the endpoint itself, timestamps on when you picked up the telemetry in your analytic platform, and it just allows you to still establish sort of an after-the-fact kind of approach. So if the EDR is not able to detect the time-based attacks, I don't know if Elastic does that, I need to check. But again, if you're collecting the telemetry, I always think it's easy to create the detections that can detect for those scenarios.
Thank you.
Thanks for the question.
Thanks again for the talk, it was amazing.
Thank you very much.
Please give him a round of applause. Thank you so much.
All right, thank you very much. Thank you.
Thank you very much. Might be a bit too long. Yeah. Yeah, it would probably be wrong. No, just starting with you. Okay, perfect. I will have a timer, but just in case that you... Ja, maar dat is een Well done, man. Yeah, I saw that. Yeah, for sure, man. Thank you very much. That was really good. John, I wanted to ask you, for the clicker. I don't have a presentation. Oh, okay. I want to ask you. Oh, I thought you were presenting. No, I'm no. Can you give me the other three? I know it's Hello. Hi. Will there have to be a problem? Oh, you no.
Yeah. One second.
All right, so the last talk, but definitely not least, so we have Nue here on the stage, and he's going to talk about detect and defend against business logic attacks in APIs. Nue, the
Hello.
stage is yours.
Yeah, hello. Hi, everyone. Welcome. This is the last talk of the tech track. I hope you are not too tired. I'll try to make this as interesting as possible. So today we're going to talk about abusing the rules, finding business logic attacks, but I kind of focused on our latest research, which is about vibe-coded applications. So welcome. Oh, shit. Oh, well, why did it? Okay, the clicker is not on my side. So my name is Noé. I'm a research and development engineer at Escape. I lead the ASM project. And basically, my job is to automate discovery and pen testing. I'm kind of an at-scale nerd, so I love to take stuff and running at a large scale, like internet scale. And I do open source too. Oh, wow, the clicker is really buggy. Sorry for that. OK, so what's Escape? Escape is an automated pen testing platform. And we do everything from discovery to security testing. And we try to automate this process. Okay, so at Escape, we have a habit of doing research on exposed applications. We've published several reports. Today, we are going to focus on the state of security of vibe-coded applications. You can read the full report here. I will, of course, not have time to present everything in the report, so this will be like a synthetic view of that. But there it is. The clicker is really buggy. So first, little introduction. What is vibe coding and how did we get to from LLMs to vibe coding? So as you all know, there has been a big rise in adoption of LLMs to generate code around 2023 with just plain ChatGPT or tools in your browser where you will outside of your IDE, you will just prompt the LLM and then copy paste the code and run it wherever you want. Then we started to see some tools appearing inside of the IDEs, the first one being GitHub Copilot, and then some more advanced tools like Cursor or Cloud Code, which run directly close to your code. And this created a trend, which is called vibe coding, which is you just prompt the agent, you never touch the code, and you let the AI do everything on its own. And now we see a shift to full AI platforms like Lovable or Base44, which brings it back out of the IDE. And the idea is that you just have a chat interface, but the platform will deploy the code for you, will deploy the front end, the back end, set up everything, the infrastructure you need, and basically just generate your application. So, little question to the audience. How many of you do use LLMs or AI in your day-to-day job? Yeah, basically almost everyone. And is it to code? Who does use it to code? Yeah, a lot of people too. So you probably have the same gut feeling as I do. The LLMs, they create weird results, bugs, hallucinations. And they do even when you supervise them. So probably fully AI-generated code might be worse. Also, those platforms, they lead to unreviewed code. It's completely obscure. You never see the code you are running. And it's also created by less technical people. The full appeal of those platforms is to bring everyone to develop code. Probably some of you have experienced your CTO vibe coding something like, hey, I have the next billion-dollar app. Let's just ship it to prod. And it's connected to your database, and you're basically screwed. And those platforms, what changed is that they can now generate the front end. This is kind of old, but now they also generate your back end and your database. And this database and this infrastructure that it generates can handle sensitive data, etc. So might be a problem that the AI is the only one in control. So we wondered there might be some security issues there. And we wanted to test that. Oh, wow. Yeah. On top of that, there is a first catalyst, which is there is a clear increase in API services count and complexity in companies in general. Our previous research identified that there is, on average, about 15,000 API endpoints per organization, which is like that many entry points to your code and that many entry points for potential vulnerabilities. Also, we found some extreme cases of organization having like 3,000 API services for a single organization, multiplied by dozens of endpoints. Very large attack surface. The second one, oh shit. Okay, sorry. The second one is there is also an increase in attacks on those APIs. This is a report by Kong, and they basically forecasted that by the end of the decade, there will be a 1,000% increase in API attacks. So if we combine all of that, so our gut feeling and those catalysts, we kind of get an explosive cocktail. The companies, they have more APIs and endpoints that they can track. Those APIs, they are more diverse and complex than ever. And there is an increase in attacks. And boom, vibe coding on top of that, there is no more human in the loop. What could go wrong? And so that's what we wanted to test. So we started trying to pen test those vibe-coded applications. So first we have to discover them. How do we build the data sets of such applications? We needed a source. Our first source was Lovable Lunch. It's like kind of dashboard, like rankings of vibe-coded applications where you can submit stuff that you made on the platform. So very easy to scrape, good source of lots of applications. We combined that to other sources. We identified some fingerprints in the JS code that those frameworks, like applications, will inject in your JS code. So we are able to take that. We also enumerated the subdomains on which they deploy the applications and other techniques. And so in the end, after filtering a bit, we get 5,000 base targets to pentest. We fed those 5,000 targets into the Escape attack surface management to perform even more discovery and security testing at scale. Basically, this platform works as the following. We take assets, which can be like of very various types. What interests us today are mostly host API services and web applications. We run that through scanners, which can be of various types too. So either ASM to do discovery or some DAS or business logic security testing to find vulnerabilities. And those scanners will output assets, so discovery, and this creates a feedback loop. And we can put those assets back into the scanners, etc., expanding the attack surface. And it will report some vulnerabilities. Let's take a look into one of those scanners, which is the main one that we used in this research. It's our web application test, because those were mostly web applications. So basically how it works is that you take the application, you start a browser, you go to the application, you crawl it with like some AI or different techniques to get into all the possible paths. And then we perform some injections and security checks to find issues. While we are doing that, we hook into the browser, so we are able to get all the JS sources of the application, and we also hook to every network call. And from that, we are able to run some passive checks to detect eventual secrets of personal information. And we also are able to extract the APIs that those front ends use and to reconstruct the schemas from the runtime requests. And we also associate that to the authentication, like we can extract the cookies or the JWT session or whatever. So after running that, we quickly discovered that Lovable uses Supabase as default to generate their backends. For those who are not aware, Supabase is basically just a Postgres as a service. And what they do is basically they generate your front end, and then they call Supabase via their LLMs and agents to configure your database and your API that is built on top of the database. And they configure everything for you, like the schema, the row-level security, which is what you use in Supabase to control which tables or objects are accessible on, or exposed in the REST API. And this raised some concerns to us, because generating your schema from an agent is probably a bad idea. Generating the access control is probably a bad idea too. And having used Supabase myself from some small projects, the RLS is easy to mess. Even if you are experienced and you know what you do, it's easy to just miss something and expose a table that you don't want to expose. And there has been a reported CVE on that, which was that Lovable was basically setting up the database with like everything is accessible first, and then trying to like control, blacklist some of the tables, which is like not what you should do. You should do the opposite, of course. So we'll try to see if we can identify this CVE. Did they fix it? They told that they kind of fixed it, but you'll see. So from this discovery, we started with about 5,000 targets. We discovered 15,000 assets in total, and out of which we extracted about 1.5 web apps that we want to pen test, and about 500 Supabase APIs. I'll just explain why we filter those and how did we do that. Basically, for the front ends, a lot of those were just like either landing page or broken or authenticated. Authenticated, sometimes it was even just like join a waiting list or something like we could not register. And so a lot of broken apps too, like vibe-coded applications were really broken, just like websites. You go to the website, it's just like 500, or you click on a button, it doesn't work, it just crashes the website. Lots of broken applications. Same for the APIs. We focused on the Supabase APIs, so we removed the rest, and we had a lot of dead APIs or broken APIs. So we focused on the green parts there. Then, okay, now that we have those targets, how do we assess the business logic security testing of those backends and those APIs? Let me explain a bit how we do that at Escape. So this is the full scheme. We start with the Lovable. For a quick recap, we run it through the ASM scanner, the scanner that I presented, and some other scanners to find some metadata, stuff that could interest us. And from that, we extract the Supabase API and the JWT that is needed to connect to it, that is usually hard-coded in the JS files. And we construct the schema for it, and then we're able to fit it in our security testing scanner. How do we do this testing? Basically, our scanner, it takes an exposed service and a schema. Then we run our technology to find business logic flows and leaking data or secrets. Let me explain how this works and why it's hard to actually assess the business logic of applications. When you try to automate pen testing of APIs, you face two main problems. The main one is that if you just randomly fuzz or you just try to brute force the API, you will not ever be able to get past the validation layer, or very unlikely. You will just send requests, and it will get rejected if the application is correct, because you do not know what to send to the API. And that caused most of your requests to be blocks, and so you end up not testing the application itself or the business logic, you just test the network layer and the validation layer, which is not interesting and which is where a lot of DAS tool fails. Our solution for that, it's a bit of a buzzword, but sorry. We use AI-driven semantic API exploration. Basically, that means that we are able to quickly learn from the API, and we are able to craft payload that will get through the validation layer to identify which of those payloads work, and then reuse them to build exploits. I will come back to that later. The second problem is that even if you are able to get past this validation layer, it's basically impossible to explore every possible combination in the API. Like, this is a classic problem when you try to break something. So what we do for that is we use reinforcement learning to build basically a tree of possible outcomes we are searching for in the API, and we prune the branches that we are not interested in. Let's take a quick example on how we do that. It's very simplified, but so you get the idea. Let's take a GraphQL mutation. I took GraphQL because it's just easier to represent than rest, but basically it's the same. We have, imagine like a hotel room booking system. We have a mutation that is book room. You should pass it like a hotel ID, which is an integer, room type, which is a string, and a guest email, which is a string too. The naive approach, very naive approach, would be to just generate random stuff and send it to the API. Of course, this will like never ever get to any code path if your API is not completely stupid. We send like 1, 2, 3 for the hotel ID, random string, random string. This only respects the schema, like the primitive types, but not the intended logic that you should send to the API. So what we do here is we combine what I mentioned before, and we basically use previous responses. Like imagine we have a query list hotels. We are able to extract stuff from that, like for instance the room type, which is like an enum, and we will reinject it. The ID too, we will list it, reinject it, and the email which we might have created from some register route or login or whatever. And then with this request, we are able to actually craft a valid payload and get deep into the code path. Once we are able to do this, we basically just export the API, map all the possibilities, prune the stuff that is not interesting, and then build chain of attacks. So basically here, very simple chain. We register, then we take the email. We could take the hotel ID room type from what I presented before, inject the guest email, and then boom, we modify the request that was legitimate and successful and just try to inject stuff in this legitimate request, which is much more likely to get deep into the API and actually find stuff. So the benefits of using that is that with a naive approach to Dast, you just basically test the network layer or the headers or whatever, and you will have issues like, hey, some control security header is missing, which is not very valuable still. Why not? But it's not what you want to test when you have pen testers. With this approach, you are able to test very complex business logic flows, such as like tenant isolation. You create 2 accounts. You check, OK, yes, I'm able to create this resource. Can I access it from the account B? Can I modify it from the account B if it was created from the account A, etc., etc. So if you want to learn more, we have an article on that too. It's very hard to explain it all in just a few words, but this was a very simplified version of it. Of course, it's much more complex, and you can read that if you're interested. So the interesting part. What did we find? Enough words. Let's go to the results of the findings. Just a little disclaimer. As I mentioned, a lot of those applications were broken or untestable. Yeah, vibe-coded applications are really broken. You can trust me on that. A lot of those were behind authentication. We are trying to automate authentication right now. We ran it a bit, but just on a tiny portion of it. It's really hard to scale. And also, we ran all of our scanners in a surface or production mode, which means we made them as harmless as possible, not to break stuff on the internet for people that did not ask us to. So we disabled a lot of checks, like very hard injections, etc., and we disabled state-altering operations like post, or like delete user, or stuff like that. But we still found quite a lot of stuff, quite a lot of nasty stuff. Around 35,000 vulnerabilities, of which we identified 100 as critical and manually reviewed the critical and high ones, 2,000 high-impact ones, and a lot of secret leaks and personal data leaks too. Let me go a bit more in depth. For the vulnerabilities, on the high ones, we had SSRF, zero-click account takeover, about 250 dependencies vulnerable with CVEs. We reconfirmed the CVE that I mentioned earlier, so they did not fix it. And we also confirmed a lot of broken access. Some file disclosure, this was pretty weird because some people actually, they generate, this was really interesting to find. Some people, they will generate it, but not deploy it on Lovable, probably because you have to pay. So they will just whack the code in their home laptop and serve it on the internet so you can access the Git repository or stuff like that, just leaking stuff on the computer. And a lot of misconfigured permission or broken access control, which came from the RLS that I mentioned before. So our guess was pretty good to say that this was probably very vulnerable. In the secrets, we identified GitHub tokens, a lot of OpenAI API keys too, because they love to build LLM wrappers. But who needs a backend when you can hard code the key in the front end? It's so much easier. So yeah, they just like throw the API key in the front end, make calls directly to ChatGPT, and ta-da, you have a wrapper. We also found some admin payments API tokens that were actually active, one of which was a Stripe token, and a lot of like passwords, JWT, blah, blah, blah. For the PII, we found medical records, IBANs, phone numbers, emails, the whole package. Let's deep dive in a few of those vulnerabilities. The first of which, it was an application that leaked all of the GitHub application tokens. So you can basically steal the GitHub apps, which can be very problematic. And this is related to the CVE that, as I was mentioning, it uses the same vector, which is basically just you bypass the row-level security by just passing a select that is select everything in the table, and ta-da. This one is a very nasty one. It was a medical platform, like connecting doctors to patients. And with a certain chain of requests, you were able to leak all of the doctor's info, containing the full name, the birth date, the phone number, the license number, which is like a medical license number, the bank IBAN, the email, the password, which is clear, of course. And you can see that this guy is a clinic psychologist. This one was really, really scary. And last one is zero-click account takeover of basically every active session on the website. So you are able just to dump all the sessions of the users, and you can just take the tokens, like impersonate someone, and do whatever you want, including the admin accounts, of course. Yeah. So to conclude, a lot can go wrong when you vibe code your front end, but a lot more can go wrong when you vibe code your backend and your database. So please don't do it. Some mitigation strategies. This is very enterprise focused, but first, try to have a continuous mapping of your attack surface, whether it's APIs, but not only like your web applications or whatever. Either do it internally, that's the best way, just like map everything right from your code. Or if you cannot do that because you are a large enterprise, you have a lot of teams, just use some tool. Escape ASM does that, but a lot of applications does that too. Do some continuous pen testing on it. Manual pen testing is amazing. I always say that like no tool, Escape or any other tool will ever replace that, but it's a very nice addition to just be able to start a scan right when you deploy your code, like from your CI/CD, and to just get all the low-hanging fruits and make sure not to deploy something too vulnerable on the internet. So do that. Third, try to apply some security by design. This is everywhere too. It's a bit of a buzzword too, but the shift left security, to try to just communicate with the developers, to inform them about security, to think about security right into the like prototyping phase or development phases. And last, please, if you do use AI to generate your code, I do too, it's great. It saves a ton of time, but review the code. And do not vibe code like your access control layer or your database schema, I beg you. So thank you. I hope you liked the talk. You can give feedback with this QR code. And if you have any question, I'll be happy to answer.
Thank you so much. We only have time for one quick question.
Thanks for the session. You said that you gathered some targets from the internet. I'm just wondering about the legality and if you faced any issues because you did it like that.
As said the previous speaker, I should have bet on this question. It's always the first question, of course. So basically, TLDR, yes, it's legal as long as you disclose the stuff and you are not using what you find in like malicious ways. It also depends on the country where you perform that. But yes, this was done in a legal environment. And no, we did not face any issue. The platform themselves, they probably didn't notice because it's just not that much traffic. We tried to make it like not so aggressive, as I mentioned. We try to send as few requests as possible, both for not destroying stuff and being fast and scalable. This is like the full thing of scaling stuff to scan. And we disclose vulnerabilities, but most of those companies, they never reply because, you know, if you just vibe code your application, you won't ever just have an email to. Some of them reply, but yeah, most of them do not and don't care. And a lot of applications were actually already pwned or pwned after that, and tokens were like revoked or, yeah. Thank you.
Thank you.
All right, let's give Noah a round of applause then. And thank you for attending the talks here, and please go to the next room for the closing ceremony.
Oh, if you want to, LinkedIn. Have that, yeah.
J'ai hésité en plus au début à dire OK, I can bet on the first question. Non, en fait, tu m'as mis sur le t-shirt. Ouais, j'ai trouvé ça. Mec, ce serait tellement drôle. Misschien dat we ja.
We dan nu tijdelijk gewoon maar even daar gaan. Of hier. Ja, het enige is hoe gaan we het netjes daarna weer en dan slepen we het daarna die kant op.